Check out this animation of a spring-loaded pin. Cool, huh? Do you want to do something similar? So stick with me till the end, cause I'm gonna show you the easiest way to model and animate a spring in Solidworks. Hey, what's up guys, this is Thiago, I'm a mechanical engineer, and in today's SolidWorks tutorial I'm gonna show you the easiest way to model and animate a Helix Spring. And the best, no special curves needed. So without further ado, let's get started. I am ready with my SolidWorks open, and I'll start by opening the assembly file to which I need to include the spring. In my case, it is this threaded spring-loaded pin. Now I'm gonna set up a section view so I can see the pin assembly's internals and the space where I'll insert the spring that's gonna be modeled in context, that is, inside the assembly. In this section, I'm gonna exclude some components that I want to keep from sectioning, like the pin and the handle. As you can see, this is the room where I'm going to include my spring. In my assembly, I also set a distance mate for maximum and minimum pin stroke, thus limiting its vertical displacement. Now I'm ready to start modeling my spring in context, that is inside the assembly. To do so, go to Assembly, Insert Components, and New Part. Now I select the front plane and start sketching the spring. I'm gonna start with this vertical line from the origin to this base of the pin. Confirming my sketch. Now I'm going to start a new sketch out of the front plane of this new inserted part. Part 6, I'll select the front plane and make a new sketch. And I'm gonna sketch a spring wire profile. In my case, it is a circular profile. I'm adjusting the distance to the center of the pin. Then I set this horizontal constraint. Now, just place the sweep feature. Select here the profile of my spring, and this vertical line as the guide for the sweep feature. Under Options and Profile Twist, select Specify Twist Value. Then, I'm gonna set the twist control to revolutions. In my case, 6 revolutions are enough to generate the spring. I'm just going to revise this winding direction so I can turn it into a right-hand Helix Spring. Then confirm the command. And there you have the spring. Now I'm gonna reconfigure this section view, keeping the spring from sectioning so I can see it as a whole. Displacing the pin, nothing seems to happen. but just rebuild the assembly using the shortcut Ctrl B so that the spring adjusts or contracts within the specified limits. But we haven't finished the modeling yet. I'll model the spring tip's finish by cutting the excesses that exceed the limits of its run. So I'll set the spring back to its start position. Then I'll rename this part to spring. And I'll edit it. Starting by isolating it from the rest of the assembly. Then I set my first sketch back to show, which is this vertical line, so it can help me with the next steps. Now I'm selecting the top plane and I'll insert the cut with surface feature. Now I check the direction of the cut and confirm the command. I'll just show, leaving the part edit. And now from the top plane, I'll set a new one, so I can cut the other tip end. Here, as a second reference, I select this end of the line. I'll rename this plane to spring length. And again, insert the cut with surface feature. Check the cut side and confirm the command. Now I can hide this vertical line, and there is the finished spring. Now I'll apply some different color to my spring. To do so, I'll exit the isolate view mode and set the view back to normal. I'll hide the screw and I'll select the material. Well, as this color is very similar to the rest of the parts, I'll highlight it by selecting another material so the spring will be a different color. For example, this bronze. It looks much better to me, right? Now I'll set the screw back to show. Let me see how it looks applying some transparency. Well, as I want to show the contour lines of the parts, I'll start the motion study through the section view. First, I'm gonna save my file. Again, I'll set my section view. Let me run one more test. Yeah, it looks right. The modeling is complete, but for the spring to compress or extend, following the pin displacement, I must rebuild the assembly using Ctrl B. But in the case of a presentation, the best thing to do is an animation. Through the animation itself, Solidworks calculates and updates the line length, and therefore the extension or contraction of the spring. So let's move on to animation. To start, select the tab Motion Study. I'll start by disabling the views playback. Now I go to my assembly constraints, and I'll find the distance mate feature I have included to limit the pen stroke. I'm going to copy the original distance with Ctrl-C and that diamond, and Ctrl-V within 5 seconds, and again in 10 seconds. I'll adjust the timeline back to the middle in 5 seconds. And I'll set the pin displacement to where the spring is fully contracted. Now I right-click on this key and replace it with the current position. I'll press this button for Solidworks to calculate the entire animation. As this process is a little slow, I'm gonna fast forward the video. Now it is possible to run the animation. On that button, I'm just gonna switch it to loop playback and run the animation. Awesome! The animation is correct. Now I'm gonna pause it, and I'll save this animation to a video file. On the Save window, configure your animation. I'll set the custom aspect ratio to 16:9 and configure this frames per second to at least 24. Solidworks is recalculating and saving the frames to build up the video. This process takes a while, so I'll fast forward the video. Solidworks has completed the video export. Now let's see the final result. I'm gonna open my AVI file here. And there is the outcome of this animation. So, did you like this video outcome? If you did, please click the like button and share it. If you have any questions or suggestions, please leave them in the comments below. See you next time, have a good one!